Hello everyone and welcome. Today we're going to talk about a really cool math trick that's like a secret shortcut. It's called exponents. And trust me, once you get the hang of them, you'll see how they make even big scary problems super simple. Have you ever had to do this? Write the same number again and again and again? It's so boring, right? And it takes up so much space on your page. There has to be a better way. And there's what? There is. And here's our superhero, exponents. Seriously, think of them as the ultimate math shortcut. They give us a super neat and tidy way to write down long repetitive multiplications in a very short and simple form. To use this shortcut, you just need to know the two main players. First, you've got the big number on the bottom. We call that the base. That's the number we're actually multiplying. Then you've got the little number up top. That's the exponent, or sometimes we call it the power. That little number tells you how many times to multiply the base by itself. Okay, let's see how this works. When you see a 5 with a small 4 on top, that means 5 to the power of 4. It's just a short way of saying we need to multiply 5 by itself 4 times. So that's 5 times 5, which is 25, times 5 again is 125. And one last time, times 5 gives us 625. See, so much shorter than writing it all out. Alright, now that you know the basics, it's time to level up. You know, like in video games, exponents have some rules or laws, and once you learn these, you'll be solving problems like a total pro. Our first rule is all about multiplying. When you're multiplying two numbers that have the exact same base, there's a really easy trick. You just keep the base and you add the exponents together. Let's see how it works. So, take this for example. 2 to the power of 3 times 2 to the power of 2. The base is the same for both. It's 2. So we just add the exponents. 3 plus 2 gives us 5. So our new problem is just 2 to the power of 5, which equals 32. See? Super simple. Okay, next rule. This one is for division. And you know what? It's pretty much the opposite of multiplication. So if you're dividing two numbers with the same base, you keep the base and you just subtract the second exponent from the first one. Let's look at this one. We have 5 to the power of 6 divided by 5 to the power of 2. The base is 5 for both. So we just subtract the exponents. 6 minus 2 equals 4. And that leaves us with 5 to the power of 4, which, hey, we already know that one. It's 625. See how it all connects? Our third rule handles something you might see sometimes. It looks a little weird. It's an exponent raised to another exponent. We call it a power of a power. And the rule here is you just keep the base and multiply the two exponents together. For example, look at this. You've got 3 to the power of 2 inside the brackets and the whole thing is raised to the power of 3. All you have to do is multiply the exponents. So 2 times 3, which gives us 3 to the power of 6. And that equals 729. A problem that looked really tricky is actually very easy with this rule. You're doing awesome! You've learned the main rules. Now it's time to unlock some special powers. These are a few unique cases that have really simple but very, very important rules. First up, the zero power. This one honestly feels like a magic trick. Any number, I don't care how big or small, if it's raised to the power of 0, the answer is always 1. That's it. 1,000,000 to the power of 0, it's 1. The only little catch is that this rule doesn't work for 0 itself. Now, what if you see a negative exponent? Don't worry, it doesn't mean the answer is going to be a negative number. It's actually a flip move. A number raised to a negative power just flips and becomes a fraction. It's 1 divided by that same number with a positive power. You just flip it downstairs. Okay, now what happens if the base itself, the big number, is negative? The key is to look at the exponent. If the exponent is an even number like 2 or 4, the negative signs will cancel out and your answer will be positive. But if the exponent is an odd number like 3 or 5, your answer is going to stay negative. Now, for something really practical, have you ever tried to write a number with like 10 or 15 zeros? It's such a headache. Well, exponents are here to save the day with something called scientific notation. Just look at the difference. It's like night and day. On the left, you have the long, messy way of writing a number. And on the right, you have the exact same number, but it's so clean and easy to read. This is where exponents are amazing. They help us work with giant numbers and teeny tiny numbers so easily. So, how does it work? Well, you just write the number so it's between 1 and 10. For 12,30,000, we put a decimal point after the first number to make it 1.23. Then, you just count how many places you move the decimal point. Here we moved it 6 places, so it becomes 1.23 times 10 to the power of 6. Simple. And you know what the best part is? Comparing huge numbers is suddenly so simple. You don't have to count all the digits anymore. Just look at the exponent on the 10. Whichever number has the higher power of 10 is the bigger number. It's a fantastic shortcut that scientists and engineers use all the time. So you might be thinking, okay, hey, this is kind of cool, but am I ever actually going to use this stuff? And the answer is a huge yes. Absolutely. Exponents are literally everywhere. Massive things like how far away the stars are, and also microscopic things like the size of a single atom. So, there you have it. Exponents aren't just some random numbers in your textbook. They are a real superpower that helps us understand and talk about the world in a much easier way. From saving you time on your homework to measuring the whole universe. So, I only have one question left for you. Now that you have these math superpowers, what are you going to use them for?